and welcome to a session on color in lighting. As we discussed in earlier papers, that light is radiant energy made aware to a human observer by stimulating the retina of the eye and producing a visual sensation. Light defined in this way is a psychophysical concept. It is better to say that in the broader sense, color and light are practically synonymous. When similar radiant energy is made to pass through a triangular prism of glass, we call the observed result, as it stimulates the retina, a spectrum or band of color composed of violet, blue, green, yellow, orange and red. These wavelengths from 400 millmicrons to 700 millmicrons, and thus they form the visible spectrum. According to the strict interpretation of our definition, it is not accurate to precise to attribute colors to objects, but only to the light reflected from them. When the radiant energy falls on the object and its color is nothing more than its ability to modify the light incident upon it. The object absorbs certain wavelengths, others reach the retina of the observer. The color of an object then depends on 1. The spectral distribution of incident radiant energy, 2. Selective absorption, and 3. The psychophysical function of human vision. Now, we shall look at how the light falls on the objects and what is really happening. When light falls on the surface of an object, one of the three things can happen. The light may be absorbed, reflected or transmitted. The object could also be self-luminous. When radiant energy falls on an object, that is ordinarily called red, the way it appears in daylight. Other wavelengths are absorbed, and red wavelengths, if any are present, are reflected to the eye of the observer, who perceives the object as being what we call red. This is selective reflection. If the red material is transparent, less energy may be reflected from the surface, but essentially the material transmits red and absorbs the other wavelengths. Here, I will try to describe what the connection between lights and colors are. Brightness or lightness then is the attribute of color that makes it equivalent to one member of an achromatic series ranging from very dim to very bright, brightness, and from black to white. The definition of the other two attributes of color are follows. Hue is that attribute of color that permits it to be classified as red, orange, yellow, green, blue-green, blue, violet, and so forth. Chromatic colors are those possessing hue. Achromatic colors are those that have no hue. That is, they correspond to the gray scale mentioned below and range from very dim to very bright. Saturation is that attribute of any chromatic color that determines its degree of difference from the achromatic color that it resembles most closely. These three, brightness, hue, and saturation, are the common terms for the attributes of color sensation, especially in discussion of light and color. There are innumerable color systems, some with color solids, in which there is a vertical axis that forms a grayscale, with white at the top and black at the bottom. These three variables are hue, chroma, and value, which correspond roughly to hue, saturation, and brightness or lightness. Color symbolism. The related subject of color symbolism is fraught with many contradictions and is used with many pitfalls. For certain plays, nevertheless, there is a definite place for symbolism in costume and lighting. In such cases, if it is used with clarity and simplicity, it should be successful. There is considerable divergency of opinion, and colors certainly do affect people in a great variety of ways. For these reasons, it has been considered of sufficient importance to mention some of the ideas and to present a list of the things that colors are said to symbolize and suggest. In some cases, there is substantial agreement. Red, orange and yellow are commonly called warm hues, and blue and green are said to be cool. A certain hue of red may suggest murder because blood is associated with murder. It also suggests anger, perhaps because a bull is supposed to be angered by red. Green is generally agreed upon as suggesting envy under certain conditions. Color on the stage is used primarily, of course, for other reasons, but it has been divorced sometimes by accident that color affects an audience emotionally, at times objectionably so. The atmosphere of a scene or complete play often suggests certain hues to an artist. To be sure, the same play probably suggests entirely different hues to another artist. It is difficult to say who is right. Therefore, it brings us to a clue to the mystery of the many conflicting ideas associated with various hues. Color can be used with various other things that influence the impression it makes on an audience, that one can never state arbitrarily what hue symbolizes unless the circumstances are included. Now, we will look at the various ideas which are associated with a single hue. White. White is a symbol of light, purity, chastity, innocence, truth, modesty, peace, femininity, delicacy, sacrifice and infirmity. White is cold, hard, cruel and sometimes symbol of mourning. Black. Black in many respects is opposed to white. It expresses gloom, darkness, woe, night, death, mystery, horror, terror, evil, wickedness, crime and mourning. Grey. Grey represents one of the series step from white to black, is less severe than black. Grey symbolizes humanity, melancholy, resolution, solemnity, age, penance, sadness and mature judgment. Red, classed as a warm hue, suggests blood, heat, fire, anger, hatred, murder, tragedy, shame and destruction. It can symbolize power, vigor, health and passion. Orange. Orange is a warm hue. Its symbol autumn, harvest, warmth, plenty, laughter and contentment. Yellow. Yellow is also a warm hue, suggests heat, liveliness, gaiety, gaudiness and in some instances cowardice, indecency, decay and sickness. Brown. Brown also signifies warmth, harvest, plenty and happiness. Green. Green suggests youth, vigor, spring, immaturity, contemplation, faith, peace, solitude, life, victory and sometimes jealousy. Blue. Blue symbolizes coldness, melancholy, the sky, the sea, heaven, hope, intelligence, generosity, truth, spirituality and aristocracy. Violet. Violet signifies sadness, quietness, purity, love, royalty and wealth. Purple. Purple suggests royalty, heroic, virtue and wealth. These are the general aspects that related with the meanings of colors. Sometimes, according to the artist, this can be changed, or when one individual is looking his or her own ideas of color, it may be able to change according to the need. There is two systems to understand surface colors and their variables. additive and subtractive mixtures. As I mentioned earlier, when light strikes an object, it is reflected, absorbed or transmitted. If the object is transparent, a small amount of light is reflected and certain wavelengths are absorbed while others are transmitted. This is considered a subtractive mixture. When white light falls on a transparent red color medium, a small amount of light is reflected from the surface. The exact quantity depending on the angle at which the light strikes the surface. Red is transmitted and the remainder of the white light is absorbed. If a transparent green filter were placed in the path of the red light, then red would be absorbed by the green filter and nothing would be transmitted. When two different lights with different wavelength distributions, such as red and green, fall on the same surface and are reflected to the eye, they reach the eye as a single distribution. In this case, yellow, green is added to red and reaches the eye as yellow. This is called an additive mixture. All of the change that occurs in light before it reaches the eye work according to the additive or subtractive process. Additive primaries. White light is a mixture of the visible wavelengths from 400 to 700 microns. When light passes through a prism to form a band of color, the separate colors are usually recognized as violet, blue, green, yellow, orange and red. Sir Isaac Newton was the first to observe this, and later it was discovered that if three widely separated colors, blue, green and red, are projected onto a white surface, it is possible to match the appearance of any other part of the spectrum. All three of these together will produce white light. There are also a large number of pairs of colors that when mixed will produce white. For example, blue and yellow, complementary colors. For practical use in the theatre, it is possible to use three saturated glass or plastic transparent color filters, blue, green and red, for the additive primaries. The principle involved in understanding the additive primaries can be illustrated best by reference to the equilateral triangle shown and the upper color diagram in plate 1. Here, light is being mixed from 2 to 3 separate light sources, each with a primary color medium covering the incandescent lamp. In stage lighting terms, 3 color filters are each being placed in front of the lens of a spotlight, and they are projecting their beams to a single area. Blue and green in various proportions will obviously produce all of the possibilities from a slightly bluish green to a slightly greenish blue. If we accept the name magenta for the half and half mixture of blue and red, then various proportions of red and blue might be purple, through magenta to a scarlet red. Green and red additive mixtures are a little more surprising to those who are meeting the phase of color for the first time. Approximately equal parts of green and red produce yellow. With more green than red, yellow-green is produced, and with more red than green, the result will be orange. Mixtures are inclined to be brighter and less saturated than the basic primaries. Green, blue, green, yellow. White, blue, magenta, red. Additive mixture of color. When two colors such as blue, green and red, or green and magenta, or blue and yellow are projected onto a white surface, the result will be white light. Such pairs producing white are called complementary colors or complements. When all three of the primaries are mixed from three different light sources, a large number of other colors can be produced by varying the proportions of the three. After two colors are mixed and third one is added, the resultant mixture and the third color become diluted until the result is white light. This is common practice when the strip lights are wired in three circuits and the lamps are covered with primary blue, green and red color media. Projected onto light blue cyclorama, an approximately equal mixture of the three reveals the cyclorama as a day-light sky. By adjusting dimmer readings on these three color circuits, one can produce the various tints and colors of a sunset, after which one can gradually dim out the red and green to the desired dark blue for color on the same cyclorama that resembles that of a night sky. Although primary colors are rarely used in spotlights for acting area, light tints of blue, blue-green, yellow, violet and red are common and are used in spotlights where two focused on one area. If in stylized production one wishes to exaggerate the color in shade or shadows, complementary saturated colors can be used in spotlights, depending on the additive mixture to produce white highlights and a white undistorting mixture on the makeup, while the saturated color falls in the folds of the costumes, one color on one side, the other on the opposite side. Subtractive mixtures. When light is transmitted or absorbed selectively, some wavelengths are subtracted, so less light reaches the eye than the original amount emanating from the source. This is subtractive process. Our general understanding of primary colors is that a few fundamental colors are capable of being combined to produce a great many others. One should think of this subtractive mixing as the placement of one transparent color medium, such as a colored gelatin filter, over another. In fact, this is actually done in stage lighting practice when one fails to find in stock the exact tint needed. If a daylight blue filter seems to be too green for a particular costume or makeup color, a lavender, pale magenta, filter can be placed over it to produce a color that is nearer to pure blue. Theoretically, a subtractive primary would have to transmit more than a narrow band of spectral energy in order to fulfill the requirement that two colors superimposed produce a third color. For example, both blue, green and magenta will transmit blue because they have blue in them, but blue and red have nothing common to transmit. So, theoretically they will transmit nothing when superimposed. In practice, however, there are few, if any, color filters that are so selective. Nearly all blue filters transmit a small amount of green or blue-green. Pigment mixtures. Transparent watercolors mix according to subtractive principles. There are many pigments are not transparent. Opaque pigment particles may cover one another so that only the top layer will reflect certain wavelengths. When placed side by side, will produce results according to the additive mixture principle. If a surface is painted with small dots or two different colors and viewed at a distance, the eye does not see the separate dots. If the dots are blue and yellow, this surface will appear grey when seen at a distance, a white light. This is an additive mixture because the blue and yellow reflected from the dots mix before they reach the eye. Although we might call this mixture white light, the whiteness level of such a surface would not be high enough to call the surface white. It might be a medium grey depending on the average lightness of the blue and yellow. Since the behavior of the pigment mixtures may be either additive or subtractive, it is difficult to predict the results of mixtures except by experience with specific pigments. The spatter method of scene painting is essentially an additive mixture, unless the pigments are transparent and some of the dots cover others, in which case light can pass through transparent dots, and this part of the result is subtractive. Color selection is very important matter in theatre lighting. Here we have been discussing about various colors which is available and close together. The connection between lights and colors when they are using on acting area and cyclorama. There is nothing in it but an unsaturated pink or arranged pink that is very low in light transmission. As I mentioned before, highly saturated colors are distort mode, and atmosphere not only this but also makeup and costume too much and are rarely used for the acting area. We have seen how the primary colors will work each other. I shall be discussing the other aspects of color in the next paper, especially when we think about light, costume, light and makeup, etc. Let us summarize the main ideas we have studied. Good lighting designer should know the relationship of light and other pigments which have been used in theatre lighting. One should be aware of selecting the pigments which have distinctly different appearance in two or more colors in light. One might think of the colors according to the principle before going to draw the design. Such things have to be very well done to have any measure of success, and such a drop could not be shown in its entirely. If only a part of it were seen through windows, it might be satisfactory. Such things are too spectacular for drama, but the effects that we needed are always in demand. For these reasons, it has been considered of sufficient importance to mention some of the ideas and to present a list of the things that colors are said to symbolize and suggest. To use color effectively for theatre purpose, one must always consider the form, associated hues and all of the surrounding elements that influences the emotional and symbolic value of color. Now, you can try to answer the questions given here. Explain about color symbolism in theatre lighting. Write a short note about the additive mixtures. Write about the natural lights and colors. What is subtractive mixture and how it works? How could you relate color psychology to your mood except the general aspects of colors? Hope that you may go through the reference books for further reading. Basic Colors and Interpretation of the Oswald Color System, authored by Egbert Jacobson, published in Chicago, Theobald. Essentials of Stage Lighting, 2nd edition, by Hunton D. Selman and Merrill Leslie. Thank you for watching this program. We can meet again with another topic soon. Have a nice day.